disk swirling around a supermassive black hole. So in the visible, you see a small blue flame coming off of the torch. But in the infrared, you can see that the heat from the torch extends much, much further out. Similarly, with the radio jets, what you see in the optical is actually quite different from what you see in radio waves.
A typical lobe might be 160,000 light years as the lobe spreads out on both sides of the galaxy. That's about twice the size of the Milky Way galaxy's disk.
Astronomers think radio lobes are powered by supermassive black holes located in quasars. These are the luminous centers of most active galaxies.
The jets of radio energy that come from a giant black hole and make these enormous radio lobe structures are very closely related to quasars. In fact, in some cases, you can see a low-power quasar in the center of the galaxy, and then it's surrounded by these giant lobes to either side. They've been blasted out by very high-energy jets of electrons that are basically moving at almost the speed of light. And they are blasted out probably from the north and south poles of a spinning black hole.
The radio lobes depend on matter going down the black hole. As matter goes down the black hole, some of it gets accelerated up into these lobes. So the size of the lobes has something to do with the history of how much matter the black hole was actually fed on. And so over time, they'll change size.
Radio telescopes have surveyed the universe and determined the largest known radio lobe. The undeniable record holder is located in the galaxy named 3C236, which is in the constellation Leo Minor. Its jets span 40 million light years across. Scientists don't understand why some active galaxies form these jets and others don't. But one thing's certain, radio lobes will not last forever. Perhaps for only a few million years.
So just as this torch will eventually run out of gas and shut itself off, the jets from a radio galaxy will eventually die as well. When the black hole has consumed all of the material in its immediate vicinity, there'll be nothing left of the accretion disk to get shot out along the magnetic field lines, and the jet will die.
If black holes are the producers of these gigantic radio lobes, then what is the largest black hole in the universe? Scientists are currently placing bets on the winner. When it comes to the biggest things in the universe, some black holes earn a place in the record books. A black hole is a region of space where the pull of gravity is so immense that nothing can escape it, not even light. There are billions upon billions of these black monsters prowling the universe. They come in two size categories. Most of them are the stellar mass black holes, which are about 5 to 100 times the mass of our sun. And then there are the supermassive black holes that are millions to billions of times the mass of the sun.
We have the supermassive black holes, the kind that we seem to be finding in the centers of every galaxy where we've had the resources to look. Havoc is wrought upon your environment if you're a star orbiting close to one of these supermassive black holes in the centers of these galaxies.
Black holes are not physically large regions, but when measuring their mass, they become top competitors in the galactic heavyweight division.
The center of our Milky Way, we know that there's a black hole that's about maybe 3 million times the mass of our own sun. And yet, because black holes are so incredibly dense, the actual size of the black hole is still fairly small, but incredibly, incredibly powerful gravitationally.
As their name suggests, these black beasts are essentially black because no light can escape them. So one can only be observed when its gravity affects something else in space, such as a passing star. or when it's gorging on matter around it. So, what is the reigning black hole champion?
Which has the prosaic-sounding name HS 1946 plus 7658. Why do I say it's the largest black hole? Because we know it is the most luminous quasar in the universe that's been found so far. The black hole that's holding it together, that's producing the energy, needs to be about 10 billion times the mass of the sun. That corresponds to a black hole which is larger than our entire solar system. In fact, it's just out there to remind us how bizarre a seemingly simple force like gravity can actually be.
The largest supermassive black hole wields power in the center of a galaxy. But there are other big luminous objects in the universe. In fact, there are some that seem to exist everywhere we look. When we glance into the nighttime sky, we see stars, twinkling dots of light that are actually luminous balls of plasma. Although they may seem small from Earth, stars come in a variety of sizes, from red dwarfs, which are about 1/12 the mass of our sun, to blue-white supergiants that can get as big as 150 solar masses. Our Milky Way holds 100 billion stars, including our sun, which is over 300,000 times the mass of planet Earth. And this cosmic beacon is a literal powerhouse in our solar system.
This natural gas power plant produces about 300 megawatts of power. Now that's enough to power a few 100,000 homes. But that's only a tiny fraction of our sun's energy output. The sun's power is about 2 billion times the amount of this plant. So even in spite of its distance, the sun is able to warm our entire planet.
Even so, our sun isn't the largest or the most powerful star by a long shot.
The most powerful stars are about 1 million times as powerful as the sun. So if you wanted to compare that with the Hoover Dam, you would need 30 million Hoover Dams per person on the planet to generate that much power. There's really no human scale to imagine this power output.
The largest and most powerful stars that produce this kind of energy are called red hypergiants.
That's a class of stars that's even larger than supergiant stars. So typically stars, like our sun, are fusing hydrogen into helium to make their energy. But hypergiant stars have already exhausted all the hydrogen in their core, and they're fusing hydrogen into helium in the outskirts around the core, and that makes them extremely hot and energetic, and all that energy causes the star to swell up. And so the star ends up with a very large surface area. Surface areas of the size of the Earth's orbit or even bigger.
Within the hefty field of red hypergiants, VY Canis Majoris appears to have the largest diameter. It's 2,000 times wider than our sun, and consequently, it would take the world's fastest race car 2,600 years to circle it once. This stellar champ lives about 5,000 light years from Earth in the constellation Canis Majoris.
If you replace the sun with VY Canis